So we're going to finish up the quadratic formula today. That'll be the end of our unit, and then we will review what we need to review. Kayla, go ahead. The word problem number 49. All right. So what we've got here is a model of the daily profits of a gas station. So essentially, just so you're aware, if I put in $0 of gas, I am going to owe $16,800 for the day in costs. Because a gas station makes money mostly on gas and then a little bit of the stuff they sell inside. All right? So we're going to use the discriminant to find whether whether the station can profit $4,000 per day. Okay? So the first thing we're going to do is we're going to find the discriminant. So we have negative b. I'm sorry, not negative b. That's kind of absurd. It's b squared minus 4ac. So that would be 34,500 squared minus 4 times negative 15,000 times negative 16,800. Off the top of my head, I don't think I know that number, so I'm going to run over here for a moment. So that is going to be our discriminant, 182250000. So we definitely have two real solutions, right? There's two places where it will cross what we would call the profit line. So it will reach the profit line at some point. Agreed? Mm-hmm. The question is, will it reach a profit of 4,000? So that was if it was there. But if my profit here, look at my profit. Yesterday we talked about that baseball game, right? If we had replaced 4,000 in the profit, then I would have changed negative 16 to negative 20,800 because I would be subtracting 4,000 from both sides. Agreed? Yeah. So let's use the discriminant one more time. Let's check it one more time. Let's go back to what we were using. When we realized a profit of 4,000 or wanted a profit of 4,000, we would have replaced P. At that point, we would have subtracted it and placed it over here, which would have made that negative 20,800. That changes our discriminant from that positive value to a negative value. A negative value has how many complex solutions? Two, but no real solutions. So there is no possible way that this particular gas station will realize a profit of $4,000. Because our discriminant was negative, we had zero real solutions. Let's look at this on a graph for just a moment mentally. Let's look how it would look. If this was on a graph, originally you would have an equation that looked like this. That there is a profitable area. You see the profitable area, you can find it right there. However, since technically we're trying to get a profit of 4,000, we are going to move the entire graph down 4,000 units, which is essentially creating a new cap at 0. Because to solve a quadratic is different than a linear. If I wanted to know if it was 4,000 with a linear, I would simply draw a line at 4,000. But with a quadratic, this 4,000 line needs to become our new x-axis. So I move the entire graph down 4,000 by subtracting 4,000. And that's what has occurred. That's why we can figure out the solution. So we are going to go to number 53. Put that over here. Maybe we'll come back to that later if we have a question on it. And what we're doing here is we are going to be approximating a decimal answer. Did you get a root answer?
No.
Okay. So just read off number 53 for me then.
7x squared minus 12x plus 3 equals 0.
So lucky for us, step 1 is done. It's already set equal to 0. So step 2 is write down A, B, and C. A is 7. B is negative 12. And C is 3. Using the quadratic formula, we will put in negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times 7 times 3 all over 2 times 7. So if you notice, our beginning step is still just use quadratic formula. Simplifying this, you would get 12 plus or minus the square root of 144 minus 84 over 14. So let's move that over here for just a moment so we can get some work on the right. We're going to do the rest of the work over here. That'll be 12 plus or minus the square root of 60 over 14. Well, at that point, we kind of have to reduce. And our rules for reducing up until now said the following. We would have 12 plus or minus 2 root 15 over 14. 4 goes into 60 15 times. This 12, that 2, that 14 would cancel, and I would have 6 plus or minus root 15 over 7. Okay? Now that I have 6 plus or minus root 15 over 7, I have to kind of determine what my question is actually asking. And the question has asked you to round to the nearest hundredth. For our purposes, since we are not using a calculator, I would accept this. If we were in fact using a calculator, you would do the following. You would write 6 plus root 15 over 7 and 6 minus root 15 divided by 7. And you would do both of those, and you would get two separate answers, one being positive and one being negative. So number 17, let's move this over here, get it out of the way. Number 17 is x squared minus 15x plus 56 equals 0. So A is 1, B is negative 15, C is positive 56. And you end up with negative of negative 15 plus or minus the square root of negative 15 squared is going to be positive, so I don't actually have to write that negative anymore. Minus 4 times 1 times 56, all divided by 2 times 1. That will be 15 plus or minus the square root of 225 minus 224, divided by 2. 225 minus 224 is 1. Square root of 1 is 1. So what do you end up with? You end up with 15 plus or minus 1 divided by 2. 15 plus 1 divided by 2 is 8. 15 minus 1 divided by 2 is 7. So x equals 8 and 7. All right, let's go back to that first problem that we looked at. Okay, it's really deep inside here, okay? So there's this problem. And the first problem here, the first time we took the discriminant without regards to a profit of 4,000. We simply took the discriminant with regards to any profit. And at any profit, we found that the value was positive. I just circled it. So there is a profitable area. Okay? But the question became, well, is it possible to get a profit of 4,000? So we put 4,000 into our profit region. Solving it, that changes negative 16,800 into negative 20,800. And once we show that there's a profit of 4,000, that's our goal. The question is, are we currently sustainable? Are we currently able to make that profit? All we need is for our quadratic to somehow reach the x-axis of 4,000 to show that there is a profitable region. However, when I showed that there was a $4,000 profit, my discriminant became negative, which means this $4,000 region up here, my quadratic never reached 4,000 because I have two complex solutions. So since I never reached 4,000, I couldn't possibly have a profit of 4,000 no matter what I did for a daily value.